Alrighty, 25. Man flies a kite. So here we go. Uh, at height of 50 meters. Okay, so we've got this guy. Here's a guy standing here flying a kite. That's 50. Height of 50 meters. Wind carries the kite horizontally away from him at a rate of 10 meters per second. So here's the kite up here. And we know this height is 50 meters. And we know that wind is blowing that way at 10 meters per second. So the idea here is just to put all this information on a picture. How fast is the distance between the man and the kite changing? So man and the kite changing, if this is C, then they were trying to find dc dt. So if this distance here, if this is x and this is 50, then I've got my right triangle right here. And I can write an expression between x, c, and 50, and then the derivative is going to give me dx dt, dc dt, and then the derivative of 50, because this is a constant, notice. Right, the x is changing and the c is changing. So that's what we're trying to find. So I know x squared plus 50 squared equals c squared. So 2x dx dt, derivative of 50 squared is 0, equals 2c dc dt. And so now I can plug in 2 times, I don't know x, do I? Let's see, it says how fast is the distance when the kite, how fast is it changing, and the kite changing when the kite is 130 meters away from him. So that's when c is 150. So 2 times 150 dc dt. So when this is 150, you have to figure out what x is. So I've got my little triangle down here. 50, 150, x. So I've got to figure that out. 50 squared plus x squared is 150 squared. So I'm going to do that on my calculator. I'll pause it, save time. Oh, she's sorry. I just got done pausing and then I give you a nice sniffle. X is 141.4 meters. So then I've plugged that in up here. 2 times 141.4 dx dt. Oh, what a mess as I'm writing it. So there's your equation that you want to solve. And if you do that, you should get down here dc dt equals 9.2 meters per second. Okay, so there is 25. Okay, let's take a look at 27. Points. Find the points of discontinuity and use area to evaluate the integral. Well, on 27, this right here is the integral from negative 8 to 4 of x plus 1 times x minus 1 over x plus 1 dx, which is negative 8 to 4 of x minus 1 dx. So that graph, I'm going to put it down here, looks like this. Okay, x minus 1, it's got a slope of 1, y-intercept of negative 1, from negative 8 to 4. And notice there's a hole at negative 1. So the way that we would really do this integral is we do the integral from negative 8 to negative 1 of x minus 1 dx plus the integral from negative 1 to 4 of x minus 1 dx. Right, so I'd calculate this area and then plus this area plus that area. Now since the integral is signed, the area below the axis is going to be negative, above is going to be positive. So what it really amounts to doing is figuring out this whole area down here, which is negative, plus that area. Okay, so this is going to be negative 8. This height right here, well actually this negative 8 minus 1, so this is going to be negative 9 is this height here. And this distance is negative 8, that's at 1. So this is 9. So this area here is 1/2 base times height. 9 times 9 is 81, negative 81 over 2. And this height here is 3 is the base, and the height is 4 minus 1 because the line is 4 minus 1, or x minus 1. So 3 times 3 over 2, or 9 over 2. So it'd be negative 81 over 2 plus 9 over 2, which is 81 plus 9, or negative 81 plus 9 is negative 72 over 2. Okay, which is, where it's discontinuous. Oh, why is that not okay here? And I think I did this with somebody earlier, and this didn't seem like the answer choice was on here either. Because the answer said, they say it's D. Certainly the let's see here, find out where it's discontinuous. Well, first of all, it's discontinuous at negative 1. And so they're saying find where it's they say it's D, so I know it's certainly not that. So I'm going to go with discontinuous at x equals negative 1, the area, or not the area, the integral from negative 8 to 4 of the whole function is negative 72 over 2, which is negative 36. Okay, so that's what we're going with. Alright, let's look at 42. See if we can locate that one. Skipping ahead. .42 is this guy right here. That says solve this initial value problem, and it's dy dx equals e to the x, and that's actually minus y up top. I know it kind of looks like it might be a big y, but it has to be minus y for us to separate them. So you have to look at this as e to the x times e to the negative y. And so when I separate it, it becomes dy over e to the minus y equals e to the x dx. Right, if I divide by this. So then this becomes e to the y dy equals e to the x dx. Now that's the hardest part, because once you get to there, and now I take the integral of both sides, this just becomes e to the y equals e to the x plus a constant. And now I'm going to go ahead and plug in my initial condition, and I get when x is 0, y is 3, so it's e to the third equals e to the 0 plus c. So c equals, well, let me go ahead and write it out. E to the third equals 1 plus c. c equals e to the third minus 1. So I've got e to the y equals e to the x plus e to the third minus 1. And now I'll get by itself, so I'm going to rewrite this as a log statement. So it's log base e of this other side, e to the x plus e to the third minus 1 equals y. Okay, and this log base e, of course, is natural log. And so I end up with a right there. Okay. And then 43, take a look at that guy. This is velocity. Particle starts at 2 when t is 0, so that's the initial location. What's the position at the end of the trip? Well, the end of the trip, or its position, is going to be where it ends up how far, where does it end up at the end of 8 seconds? Well, if it starts at 2, how far does it go? Well, from 0 to 1, it goes to the left this area. From 1 to 6, it goes that far to the right, and then it goes back to the left this area. Okay, so if I go ahead and calculate those areas, this area here is 2 times 1 is 2, times divided by 2 is 1, so that's negative 1. This area here is 2 times 1 divided by 2 is negative 1. And then this area is my trapezoid, so this is going to be 1/2 base 2, so that's going to be 5 times, and that looks like it's going to be 2, and that comes down to 4, so it's going to be 2 plus 5, base 1 plus base 2 times the height. So those cancel, so it's going to be 7. Okay, so this thing starts at 2. So here's a particle. Here's 0. Starts at 2, moves negative 1 to the left, and then 7 to the right, up to 8, and then 1 to the left, 7. So that's where it's going to end up. Okay, so there we go. And then 45, let's take a look at 45. Oh man, that just hurts to look at that, but that's not the one I'm going to do, so that's good. Yeah, it is. I am 45. Oh, maybe I didn't copy 45 on here. Oh, I'm sorry. I got answers for it, so you know what? I'm going to do this. I'm going to write 45 down. 45. Oops, not 4.5, 45. It's late. I'm tired. Sorry. X equals y to the 1/3. X equals 0. Y equals 27. And it's find the volume when you revolve about the y-axis. Okay, so if I revolve this about the y-axis, all right, so this is figuring out what in the world does x equals y to the 1/3 look like. Well, that's y equals, if I cube both sides, x cubed. Okay, so y equals x cubed goes like this. Oops. Okay, and x equals 0 looks like x equals 0, y could be anything, x has to be 0 is this right here, and y equals 27 is this right here. So this is 27. So I don't think I can't get to my colors up top there, so I can't change the color. So it's this region in here, and we're going to involve that about the y-axis. So it's going to look like this is my cross section with radius r. So my delta v is going to be a circle or disk, pi r squared, and the thickness is delta y. So it'd be pi, and then the radius is how far is that? That's x units, which is y to the 1/3 squared times delta y. So the volume is going to be, I want to add up all the disks from 0 up to 27. Pi times y to the 2/3 dy. So that's going to be pi times, we can do this all together, y to the add 1, 2/3 plus 3/3 is 5/3 divided by 5/3 from 0 to 27, and then you can do the rest from there. And if you do that, you should get 729 if you simplify it over 5 pi. Okay, cubic units. And then the last one that I want to do is 46, which is, oh, the directions, I'm sorry, it's just use the shell method, and I don't want you to use the shell method, and yeah, don't worry about 46. It says use a shell method, so no worries on that. But what I do want to do is show you the answers, so you can see the answers, so you can pause on that. So there's the first 35. There's 36. And then there's the last bunch, so I said not to worry about that guy. All right, there you have it.